Good evening.
Good evening.
How are you guys? Nitish, Ansini,
Good
Vaishnavi.
evening, sir.
Good evening. Guys, anyone having any doubts related to sets? Any kind of questions? Shall we move to
Sir,
relations?
can you
Yes.
solve the last question, seventh one of the yesterday's worksheet, sir?
Seventh one of the yesterday worksheet. 1 second. A certain conference of 100 people, correct?
Yes, sir.
When it's 1 second, yes, I'm coming to that question. Is everyone? Yes, almost everyone is here. Wait for a minute and we'll start. Meanwhile, I am going to share the screen. Yeah. Hope you can able to see the screen. I think you're asking this question. Anyone?
Sir?
Anyone solved this question?
Yes, sir.
Amsini, Vaishnavi.
Yes, sir. Solve this question, sir. Sir, is this question's answer 1?
Let's see. Even I also don't know. Certain
Oh,
conference,
okay, sir.
100 people. There are 29 Indian women and 23 Indian men. Out of these Indian people, 4 are doctors and 24 are either men or doctors. There are no foreign doctors. Find the number of women doctors attending the conference. So how to check the sets here? What kind of sets you have to consider here to answer this question? What is your
So we
sets?
can directly use Venn diagram, sir.
Yeah. If you want to use a Venn diagram, what are the sets?
Sir, women, men, and doctors.
Women, men, and doctors. Is it enough?
Yes, sir.
Say foreign doctor.
Men, men, and doctors. Is it enough?
No, sir. Women, men, and doctors. Yes, sir.
So what is it? A certain conference of 100 people there are 29 Indian women and 23 Indian men. Yeah. So how the sets you are going to represent? Women, guys. Somebody said sets. What kind of sets we have to use here?
Yes, sir. Women, men, and doctors, sir.
Men, men, and doctors. N of W, how much? 29. N of men, 23.
22.
Out of these Indian people, that means total Indians are how much? N of I, whether it is required or not, N of I is how much?
52, sir.
42. I don't know whether I required this set or not, but I'm keeping whether if it required, I will use. Out of these Indian people are 4 are doctors. Out of these Indian people are 4 are doctors, 24 are either men or doctors. What is this meaning? Out of this 52, 4 are doctors, 24 are either men or doctors. What is that meaning? Men or doctors means what it is meaning?
You
Men of
men union D.
N of M union D will be equal to 24. And N of D will be equal to 4.
4, sir.
There are no foreign doctors. So find the number of women doctors attending the conference. Find the number of women doctors attending the conference. So there is a very easiest way, because here two sets only configuring here. N of M union D will be equal to N of M plus N of D minus N of M intersection D. From here, N of M union D is 24, N of M is equal to 23, N of D is equal to 4, minus N of M intersection, M intersection D will use how much? What is the answer? What is the meant by N of M intersection D?
3, sir.
This will give 24 minus 4 minus, 27 minus 24, that is 3. What is this meaning?
So the doctors who are men is R3.
Number of Indian men and doctors, correct? Men and doctors is 3. Total number of doctors, sir?
4, sir.
Out of 4, 3 are men doctors, remaining women doctors.
1.
So remaining is 1 is Indian woman doctor. How to do the same thing with Venn diagram, guys? The same question, how to do with Venn diagram? Anybody?
Yes, sir.
I'm taking one set is for men and another set is for women and another set is for doctors. You can say like this.
Yes, sir.
Yeah. So total 100 need not to be fit here. So men, women, doctors. So what is the given data? N of men will be equal to how much? Indian women 23. N of W will be equal to
Sir, N of W 19, sir. N of
29. N of W
19, sir.
29 now. How 19, man?
Oh, sorry. 29 only, sir.
Out of these Indian people are 4 are doctors and 24 are N of D union M will be equal to 24. Out of these Indian people are 4 are doctors. What is the meaning of 4 are doctors? N of D is equal to 4. Correct? Now, how to start this question in Venn diagram? Suppose if you are trying to do this Venn diagram, what I told for each and every Venn diagram, which number you have to start first?
Sir, the innermost.
Sir, intersection of all the 3 sets.
So intersection of all the 3. What is the intersection of all the 3?
0, sir. 0.
How you can say 0 here?
Sir,
Right
because
away, how you can take 0?
sir, because one person should either be men or women, sir. They can't be both at the same time.
Correct. The number of why it is 0, they didn't mention one person can't belong to 2 groups. Either the person is a man or a woman. Either it can be possible men and doctor or women and doctor. Men, women and doctor as a single person can't be available. So automatically from the data in general point of view, you have to start this value is 0. Once you got this value, what is the next thing? Which number you have to start?
Sir, M intersection W is also 0.
So M and W are, I can say M and W are disjoint sets. How many are agree with me? Why? Why disjoint sets? Guys, why disjoint sets? Anyone?
Sir, they have no common elements, sir.
Yeah, man is completely man and woman is completely woman. There is no common element. So I can say this is also 0. Am I right or wrong, guys? Either men or doctors means what? Out of Indian people, 4 are doctors. 4 are doctors means what? This region should be 4. This whole region, that whole region should be 4. This whole region should be 4. Indian people, 4 are doctors and 24 are either men or doctors. How you can deal? Compulsory, you have to use M, this formula. So in this case, Venn diagram is not so easy. Anyone done with Venn diagram without doing any formula?
Yes, sir.
How?
Sir, they said only doctors are all Indian, sir. So no foreign doctors. So the only doctor part is cut out. It's 0.
Okay, only doctor part cut out means these are also Indian men and this is Indian women now. So this whole region should be 4, correct? Indian people 4 are
The
doctors.
only sir, the only doctor's region is 0, sir. Like not the common part.
Yeah, that means this region will explains non-Indian doctors. That is also 0.
Yes, sir.
Then how to proceed next one?
Sir, I considered the intersection of M and D as X, sir.
Okay, N and M and
M, sir, men and doctors. M and D as the
is
X.
X. So automatically 29 minus X.
20,
Correct?
23 minus X, sir.
23 minus X, sorry. 23 minus X. And this is 4 minus X, correct? And this will be how much? 23 minus 4 minus X. 23 minus 4 plus X. This is 19 plus X. Am I right? Is it right? 19 plus X?
Sir, 29 minus 4 plus X, sir.
So 29 minus 4 plus X, that is 25 plus X. So indirectly you are taking the formula only here also, but it's okay, fine. So one unknown thing you are assuming as X, 25 plus X. So what is given? Union of D and M should be 24. What is the union of D and M? Are you getting union of D and M should be 24?
Yes, sir.
How?
Sir, 23 minus X.
Yes, 23 minus X plus 0 is equal to 24. What is the meaning of union? The common number should not be considered. Tell me, after that, how you proceeded?
Sir, I found out the value of X, sir, by this.
How?
Sir, 23 minus X plus 4X equals 24, sir.
Why plus 4X again?
Sir, because it's union, no, sir.
Yeah, union means 23 minus X plus 4 minus X is equals 24. 1X is cancelled.
Yes,
so 4 is cancelled. 20 is there. So X is equal to 3. If X is equal to 3, 4 minus X is equal to 1. This will be equal to 28. This will be equal to 20. So only one woman doctor from here. But compared to this, my suggestion is go for formula, because here with the two sets itself we can deal, because they gave the value of the union of two D and M. You know that N of D value, N of M value, and find the intersection. From that you can get a point. Intersection means men and doctor. So 4 minus men and doctor. It means N of doctors minus N of men and doctors will use the N of women and doctor. I'm thinking women and doctor alone. Automatically, women, men, doctor won't be available. Women and doctor. This formula also can able to use. 4 minus 3 is equal to 1. Yeah. Any other things, guys? Any other questions? Students, please respond. Any other questions? Shall we discuss? Shall I move to the next topic?
Yes, sir.
Yeah. Our next topic is relations. Our next topic is relations and functions. When it comes to definition of the relations and functions, it should be little weird because with certain assumption according to mathematicians statements, there is a difference between relations and functions. But when it comes to general point of view, sometimes based on some constraints only we are calling as some relations or functions. Yes. Before going to technically, before touching the relations concept, anyone can explain general point of view, general discussion of, suppose your friend, you went for a new school or new college and you say he is my relation. What is that meaning? Anyone?
Like you have some interaction or some common thing.
Yeah, some interaction or some common thing. Anyone can explain with some relation. A person can act as single relation or many relations. A person can act as single relation or many relations.
Yes, sir.
Yeah, I will tell you simply. Suppose if I am saying this is your family, I'm taking set A is a family. Set A is a family, father and wife and two kids. For example, two kids. Uh, one girl child and one boy, for example, and wife and husband, like one family. So I'm taking this also same set. How I can able to relate this set to another set? How I can relate? If I'm marking this one, I can get a relation. What kind of relation I get here? Wife and husband relation, correct? Guys, am I right or wrong? These two arrows shows wife and husband relation. Suppose if I am saying father and children relation, I am not saying father and daughter. If I am saying father and children relation, all these red color shows the father and children relation. Am I right or wrong? Guys, am I right or wrong? Guys, are you getting what I'm trying to say? Please.
Yes, sir.
Suppose if you see a father is acting, suppose a person is acting as a father in one case, in second case also he is acting as a father, in another case he is acting as a husband. If it is a little bit family, his father same relation will act as a son, and in some other case he will act as a brother-in-law. So one person having many relation with some other group or maybe the same group. This is general point of in our practical day relations. Correct or not? So a person can able to relate to anything. Same as I'm having one white color shirt and one black color shirt. And I'm having one gray color pant, one light blue, sky blue color pant, and one black color pant. So we are having only, this is the set of number of shirts a person is having, and this is a set of number of pants a person is having. if I'm asking how I can relate here, what is the meaning of relation? If I want a pair means what? What is the meaning of a pair in this case? If you want to wear his dress, to make a proper dress, what he want? Anyone? Nitin, Harshida, Madhumita, please.
Sir, a shirt and a pant.
One shirt and one pant compulsory he want. Correct? So, how many ways he can get? How many combination? How he can relate? He can take one shirt and one gray pant, one shirt and sky pant he can use. So here he is getting white shirt and gray pant, and white shirt and sky blue pant, a white shirt, black color pant. Same as he can use black color shirt, black color. He is having only 2 shirts and 3 pants, but he may get how many kinds of pairs he can get by relating one element to another element of the another group. Guys, please. He is getting 6 pairs, but actually he is having only 2 shirts and 3 pants. But he can able to make as 6 pairs by giving some relation between one set to another set. This is also one kind of relation I can say. Choosing on white shirt I can use as a 3 pants, and black shirts I can use as a remaining 3 pants. I am getting the 3 different combinations I am getting here. This is one combination, this is one combination, this is one combination, this is another combination. So here I am relating as a dress. I am relating as a dress. That's the reason compulsory when I am saying the relation is a dress between these 2 sets, I need one shirt and one pant, a dress for a person, male person. I need a, suppose if I am saying this set contains all the natural numbers, this set also contains all the natural numbers. I am saying the relation between this set to this set relate where set A, this is set A, set B. Set A is fully natural number, set B also fully belongs to natural number. Set A is equal to natural number, set B also natural number. Suppose if I am saying take the pairs, choose the elements in such a way, set A element is equal to set B. So how many pairs you may get here? So element of A will be equal to element of B. Suppose 1, 2, 3, 4, 5. Here also 1, 2, 3, 4, 5 and unlimited number are there. If I am saying relation means 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. Or if I am saying a number is greater than set B number. So 1, 1 won't come, but 1, 2, 2 I can write, 1, 2, 3 I can write, 1, 2, 4 I can write, 1, 2, 5 I can write. If I'm saying I need a relation where my B element is equal set 1 element plus 2. That means if I'm taking 1, 1 plus 2 is 3. I have to map for 1, 3. If I'm substituting 1, 3 is my relation, 2, 5 relation, 3, 7 relation. So like that, how many relations I can give for a one set to another set? How many ways I can develop the different kind of relations? Understand guys what I'm saying? What is the meaning of relation?
Yes, sir.
Am I confused too much? Suppose if I'm taking real point of view, if I'm taking only one person, suppose if I'm taking you means any one of you in the class, any one of you. Suppose if I'm taking Nitish, I'm taking your name. Yeah, I'm taking your name as a one set. I'm taking another set is the whole world. How many ways I can relate this set elements to this set elements? This person maybe act as a friend in one way, maybe as a brother in some other persons, maybe as a co-student for some other person, and maybe as a, how many ways? Same country person, same state person, same region, and same place, and you can map to entire your class is having 30 members in your school. He is a classmate of these 30 members, and you are coming to our academy. So you are 16 students. So Nitish is a like classmate of Epsilon Academy of 15 students of different schools. Is a senior for some other grade 10 students and junior for grade 12 students. Like this, how many ways I can relate? Got it, guys? What I'm saying? What is the meaning of relating an element to another element? Understood, guys? What I'm saying?
Yes, sir.
Yes, sir.
So if I am taking two shirts, shirt 1 and shirt 2, 3 pants, generally I am calculating S1 6 pairs I got. Suppose, sir, if I am having 100 elements here, if I am having 200 elements here, how many ways I can give the relations, and how many kind of relations I can create from one set to another set of elements? How to know? This is the actually origin of Cartesian coordinate system. From here only there is a small relation from here to our graphical system. So here initially how they found, there is a kind of ladder kind of system they can able to develop here. It's not ladder, rows and columns kind. I can say it is a rows and columns. Rows and columns means if I am writing one set as the rows, another set as the columns, number of intersections given by, suppose if I am writing S1 is here and S2 is here, and S1, S2 is in columns, and I am taking pan 1, pan 2, pan 3. And if I am drawing the horizontal lines to this, and how many places these lines are intersecting? 1, 2, 3, 4, 5, 6. So this is one relation. So here I am getting one pan, one shirt. One second, guys. Yeah, this we can give one relation. So this is also intersection of pant 1 and shirt 2. That means here I am getting another pair. Here also I am getting another pair. Here also I am getting another pair. All these 6 pairs represents a dress for a man. A dress for a man. But if it is in numbers, how many ways I can represent, how many kind of combinations I will get. This, if I am keeping one element of first set and another element of another set, is called Cartesian pair. Cartesian pair. So from here we are going to discuss Cartesian product of sets. Cartesian product of sets. Product of sets. It's simply, I can say like this. Suppose I'm having set A. Set A is having n elements. Set A is having n elements. For example, I'm taking only 2 elements. A comma B are the 2 elements. Set B is having 2 numbers. 1 comma 2 is another numbers. How many ways I can develop a relation between set A and B? There might be some relation I can develop A to 1, A to 2. There might be some relation I can develop B to 1, B to 2. So A1, A2, B1, B2. These are the possible pairs I can get from n number of ways I can relate from set A to set B. So first we have to understand how many pairs we can develop from one set to another set is known as Cartesian product of sets. It's simple. Cartesian product of sets. So how we can define, what is the condition, minimum condition required to define the Cartesian product of two sets? Anyone? The set should be a non-empty set. Two non-empty sets P and Q, for example, you can take A and B. The Cartesian product P cross Q. The Cartesian product P cross Q is the set of all ordered pairs. All ordered pairs. What are the possible ordered pairs of elements you can get from the given two sets from P and Q? Suppose if I am giving two different company balls, like a one ball one and ball two to play the cricket, you are having the three bats. How many ways you can able to play? How many combinations you can able to choose? Here are very small numbers. I can take first ball and with all three bats I can play. I can get three combinations. Second ball with all three, I can get another three combinations. But what this definition says, the P cross Q will use number of possible relations or number of possible ordered pairs from one set to another set, where the two sets are non-empty sets. P comma Q such that P belongs to P and Q belongs to Q. The total number of elements in P cross Q, the total number of elements, if I am taking P cross Q is a set, number of ordered pairs in Cartesian product of P and Q or P cross Q is known as number of elements in P into number of elements in Q. How I can say this is, see, each and every element I am mapping to, this is called mapping of an element. That means I am relating set A element to all other elements. Some relation I can create, it might be anything. So one element can able to relate all the things. Suppose if I am having C1, C2, C3, with the ball 1, I can able to map all the things. So 3 basic product formula this is. So number of columns are 3, number of rows are 2. So the number of point of intersection of these points are product of how many C's you are having, how many balls you are having, how many cricket bats you are having, how many number of balls you are having. That will use the total number of pairs you can able to choose to play. With ball 1, you can take 3 different bats and you can play. With ball 2, you can take 3 different bats. You can play total 6 ways, 6 different pairs you can get to play the cricket. That means set A to set B, you can get the 6 ordered pair. If I am mapping from number of balls to number of bats, there are 6 elements again I can get. So this kind of mapping or this kind of relating one set to another set is called Cartesian product. And what are the elements you are doing after doing the Cartesian product is called ordered pair. The meaning of ordered pair means there is a meaning. Ordered pair means, I already told you, ordered pair means the first element is belongs to set A or set P, the second element is belongs to set Q. So if I am keeping these two elements and if I am saying this is called an ordered pair, first element belongs to first set, second element belongs to second set, and there is a relation between these two sets. There is a relation between these two elements. Might be like your pant and shirt, or it might be like that one number is greater than second number. Suppose if I am saying 1, 2, 3, and this is 1, 2, 3, and I need the ordered pairs. A number is greater than set B number. P is greater than Q. So 1 is not greater than 1, 1 is not greater than 2, 1 is not greater than 3. But 3 is greater than 1, 3 is greater than 2, 3 is not greater than 3, and 2 is greater than 1. That's it. These are the ordered pairs you can get for this relation. Like this, you can get some other relations, but any relation will be within this 9 ordered pairs: 1, 1, 1, 2, 1, 3, 1, 2, 1, 2, 2, 2, 3, 3, 1, 3, 2, 3, 3. So whatever the thing you give the relate, whatever the thing you relate to one set to another set, every relation will be part of any of these 9 ordered pairs only. If I am saying set A, that means this is set A, set B. Element of set A is equal to element of set B. So what are the order pairs I will get? 1, 1, 2, 2, 3, 3. See, these are the 3 ordered pairs for a relation where A is equal to B is a part of this total number of ordered pairs. These total number of ordered pairs, how I can get? From the Cartesian product. The Cartesian product will use the maximum number of possible elements for any relation. You can take any relation, that relation elements are part of this Cartesian product only. Guys, is
Sir,
it
so can we say it like relations are the subset of Cartesian product?
superb? Relations are a subset of the Cartesian product. Cartesian product is a superset. I can say like that also. Correct? Number of relations can be developed is different. Number of relations is completely different. For that, you have to define a set, and both the sets need to be properly defined. Then only you can able to say number of relations can be developed. But any relation will be within this, the number of elements of any relation. Suppose if I am taking a person, the person, if I am saying the relation is a brother, might be he may get with the 2 persons or 3 persons based on his family size. If I am including cousin brothers also can include, means might be he will get 10 or 20 members. But the same another relation also I can give now. N number of relations I can create, but all relations having some elements. If I am saying set A element is set B, I am getting 3 ordered pairs. If I am saying A is greater than B, means I am getting 3 ordered pairs. If I am saying A is less than B, means I will get some other number of ordered pairs. Might be I will get 6 ordered pairs. And if I am saying A is equal to A plus B, that means 1 is equal to 1 plus 1, 1 plus 2, 1 plus 3, like that. If I am saying, I may get some other ordered pairs. But what are the ordered pairs I am getting? That should be within this Cartesian product elements only. Am I right, guys? Is it correct? Yes or no? So if we are able to know number of ordered pairs from one set to another set, a simple formula, product of the number of elements in set A to product of the number of elements in set B. Now, from here, mainly we are going to discuss the definition of the order pair. What is a Cartesian product? Anyone can give even your own words. What is the meaning of ordered pair? Anyone can give the what is the meaning of ordered pair? What is the meaning of ordered pair?
Pairs that are obtained from demand, like from the question, whatever the statement is given. So according to that, we get the pair.
There are two elements putting in brackets, and the order is important, and there should be a relation between these two elements. Correct? It's a well defined proper relation between this ordered pair. And I can say A comma B is not equal to B comma A. Correct? Am I right? Anyone having any definition of the ordered pair from your previous classes? Anyone? Ordered pair definition will come in Cartesian coordinate geometry. Anyone can give the ordered pair definition, guys?
Sir, order pair can will be obeying the relation given to it.
Ordered pair is two elements, particularly in our mathematics, two numbers, most of the timings, two numbers. How we can define? Which the order in which they given, which the order in which they given, in which they given Whatever the order they given, that is very important. Or specific order, or specific order. Or specific order. Anyway, anything I can include here? Is important. Anything I can include to complete the statement? Generally, we will use this ordered pair mostly in coordinate geometry to locate a position with respect to 2 points. An ordered pair, 2 numbers for which the order in which they are given is very important, and there is a relation between 2 numbers. And A comma, if I am saying A comma B is an ordered pair, and B comma A also is a different ordered pair. If I am saying 2 ordered pairs are equal, A comma B is equal to P comma Q, it is possible only when A is equal to P and B is equal to Q. So, what is the meaning is, suppose if I am saying an ordered pair, particular order pair is equal to, exactly equal to another ordered pair, means unless until if both the elements are same. So based on this, we are having a few questions. Based on this, we are having few questions. That means it's a very general point of view questions. Yeah. Suppose if I am giving, sorry guys, if an ordered pair x plus 1 comma y minus 2 is equal to 3 comma 1, find the x comma y. Whenever they are saying the given is an ordered pair, you can't change the order, and if it is equal to some other order pair, means if it is possible only x plus 1 should be equal to 3, y minus 2 must be equal to 1. So x is equal to 3 minus 1 2, and y is equal to 1 plus 2 3. This is how we can able to relate to the 2 different ordered pairs. An ordered pair is, how we will get an ordered pair? Anyone? How we will get an ordered pair? An ordered pair is a one element which we will get from Cartesian product of 2 sets. Cartesian product of 2 sets. Yeah. So one more example. From this discussion, suppose if I am saying P is a set of elements 1, 2, 3, Q is a set of elements x comma y, is my P cross Q, Q cross P, find P cross Q, find the elements of P cross Q, Q cross P, and verify whether my P cross Q or Q cross P is same or not. Got it? What I'm saying? Verify
Yes,
P cross Q is equal, and verify my P cross Q is equal to Q cross P. If not, why? First, find out the elements of P cross Q. What is the meaning of P cross Q? Means if I can relate anything from P to Q, what is possible solutions? What are the possible ordered pairs I may get? That is called P cross Q. Cartesian product gives what are the possible ordered pairs I can get when I am mapping some relation from P to Q. You know very well what is the meaning of relation. Might be it is an addition, might be it is an equal number, or might be it is an equal element or something, or might be who is working commonly, who is the same group, same school, like some relations I can create from one set to another set. So any relation, the elements of all these relations is restricted. It is based on number of elements that we can able to get from the Cartesian product. So what are the elements you are getting in Cartesian product? That is called an ordered pair. So ordered pair is an order where the order is very much important, and there is a relation between both the elements. Then only you can get the ordered pairs. That relation might be anything. So here, what are the P comma Q elements? 1 comma x, 1 comma y, 2 comma x, 2 comma y, 3 comma x, 3 comma y. Same way, if I'm taking q cross p, it is x comma 1, x comma 2, x comma 3, and y comma 1, y comma 2, y comma 3. How I can express using set relations, using the diagrammatic representation? It's very simple if there are very less number of elements. Suppose if I'm taking this is p, 1, 2, 3, this is q, and x comma y, from 1 to all elements of the q, from 2 to all elements of the q, from 3 to all elements of the q. Then you will get the p cross q. If I am mapping from p to q to p, you will get q cross p. So, is there any common order pairs are available between p cross q and q cross p? Is there any common order pairs available between p cross q and q cross p? Is there anything? Yes or no, guys? Is there any common order pairs? 1 comma x is not equal to x comma 1. Why? Because it is an ordered pair. It is 1, first element shows a, the corresponding relation is x. Here first element is x and corresponding relation is 1. If I am saying these both are equal to 1, if I am locating at 2.3 in coordinate axis, my 3.2 also same. It is not correct. 2.3 is somewhere here and 3.2 is somewhere here. These two locations are not same. These are the ordered pairs of coordinate system. This is 3 comma 2. This is 2 comma 2. Same as this is having one relation. For my 1, it related to x. If it is x, it is related to 1. But the relation is not same. That's the reason the order is important. So this ordered pair is not equal to this ordered pair. So there is no common ordered pairs between cross product of p and q and q and p. So the order of the cross product also should be important. My p cross q is never equal to q cross p. And second thing is, but number of ordered pairs in p cross q will be equal to number of ordered pairs in q cross p. If I'm considering my Cartesian product is also another set, the number of elements in this Cartesian product will be equal to number of elements in q cross p also. So these are the some other observations we can get from this example. Is it clear, guys, what I'm saying?
Yes, sir.
Yeah. So these numericals looks very simple, but when it comes to particular relation I'm talking, then it will be very much important to discuss. So those things slowly we are going to discuss in upcoming numericals. Yeah, the next one. A small exercise related to this exam point of view. These kind of questions we may face from the ordered pairs or Cartesian cross products. If set A is 1 comma 2 comma 3, set B is 3 comma 4, and set C is 4 comma 5 comma 6. Find A cross B intersection C. Guys, please start doing this question. Second, A cross B intersection A cross C. Please, if you understood, please try. I'm giving 2 minutes time or 3 minutes time. If you are not clear, I will explain. Please, what is meant by, what is the given data, what they are asking here. Anyone can explain? Anyone can explain, guys, from here? What is the given data and
Yes,
what
sir.
has to calculate? Students, please, Nitish or anyone?
Yes, sir. Sir, first in the first question we have to find B intersection C, sir, and then
Yeah.
after that we have to multiply it with the set A cross the B intersection.
Set A to set of elements of B intersection C. So B intersection C is what? What is the B intersection C? What will you get? B intersection C. 4.
4,
And
sir.
he is asking the cross product of A and B intersection. This is B intersection C. This is A. He is asking cross product, means Cartesian product of set A and set B intersection C. So the possible, whatever the relation you develop between these two sets, the possible elements of ordered pairs is 1, 4, 2, 4, 3, 4. That means you can give 100 relations from A to B intersection C. This all 100 relations, only the possible answers are any one of 3 or either all of 3 or any. From these 3 only you will get the solutions. If I am asking A cross B, the same question if I am asking what is A cross B here, can you without diagram can you say what is A cross B? What is A cross B? What are the elements in A? What are the elements in B? 1, 2, 3, 3, 4. So this will be 1, 3, 1, 4, 2, 3, 2, 4, 3, 3, 3, 4. Am I right, guys? 1, 3, 1, 4, 2, 3, 2, 4, 3, 3, 3, 4. And what about A cross C? A cross C is what? 1. How much you will get? A cross C 9 elements will come. 1, 4, 1, 5, 1, 6. And again 2, 4, 2, 5, 2, 6. Because 3 elements and there are also 3 elements. 3, 4, 3, 5, 3, 6. If I am taking the intersection between the two sets, if I am taking intersection between the two sets, so A cross B intersection A cross C. What is answer? 1, 3 is repeated? No, because 4, 5, 6. 1,
4.
1, 4,
1, 4, 2, 4, 3, 4.
3,
2, 4 and 3, 4. That means there are some relations having some common elements between A cross B and A cross C. These are the possible solutions for those relations, which is common to both Cartesian products. If any relation contains these elements and that elements are common elements for the relations when it is mapped from A to B or A to B and A to C. Is it clear, guys? So slowly we will get what is this use in math. Slowly we will understand. Once we started the graphs, once we started the range domain concept, once we started the relations concept, we will get one clarity why we need to do, why need to understand this mappings concept, number of possible ordered pairs from one set to another set, and number of relations means what, and number of possible ordered pairs for any relation is what. We will understand slowly when I am including general math into this category. If I am defining set A properly, if I am defining set B properly, and what are the relation I am defining from A to B, that relation is part of only these elements. You won't get any extra element in that relation to say that I am talking about this cross product and ordered pairs concept. Is it clear, guys? Anyone having any doubts so far? A few questions based on this. They won't ask very difficult level questions based on this. Some other out of the textbook questions also we will discuss. First, we will try to complete these textbook questions. Yeah. So, how to solve the first question as we discussed in this
Sir,
class?
first we have to find x and y. Sir.
Equate.
We have to
Simple.
substitute them.
It's an ordered pair. Whenever two ordered pairs are equal, what is that meaning?
Sir, like they are exactly equal to the other ordered pair.
First element of the ordered pair will be equal to the first element of the right hand side ordered pair. Second element should be equal to second element. So x by 3 plus 1 will be equal to 5 by 3. So from here x by 3 is equal to 5 by 3 minus 1. So this will be 5 minus 3 by 3. So 2 by 3. X is equal to 2. Correct? Same as y is a, what is the y value? What is the y value?
2/3, sir.
Anyone?
One.
Y equal
So
to
what is
Y
the
one.
value?
One,
Y is
sir.
Sorry, 1.
3/3, so y is equal to 1 and x is equal to 2. X is equal to 2, y is equal to 1 is the answer by the definition of the ordered type. What is the second one answer?
9 elements.
Second is asking number of elements. Number of elements is n of a into n of b. That is 3 into 3, it is 9. But what is the third one answer? He is asking G cross H and H cross G. He is asking the set elements. So I'm writing here 78542. When it comes to G cross H, what you will get? When it comes to
7,
G, what you will get?
1, 5, 7.
7, 2, 8, 5, 8, 4, 8, 2.
With 7, all the 3 elements. With 8, all the 3 elements. So first element is 7, 7, 5, 7, 4, 7, 2, and 8, 5, 8, 4, 8, 2. When it comes to H comma H cross G, again all different elements will come. 5, 7, 5, 8,
5, 8.
4, 7, 4, 8, 2, 7, 2, 8. Now, fourth question. State whether each of the following statements are true or false. If the statement is false, rewrite the given statement correctly. If the statements, if you decided, if you concluded the given statement is wrong, write the correct statement. P is m comma n, Q is n comma n. So P is one set, elements are m comma n. Q is another set, elements are m comma n. Because when I am writing the elements, the order of the elements is not important. So what is a P cross Q? Is this statement is right?
False, sir.
Why?
Sir, the
Sir, because
element
4
of
elements
P
should
into
come,
element
sir.
of Q will be equal to P into Q.
According to definition, it should come for 4 elements. It's
P
very
cross
simple.
Q is 4 elements.
Even
M
though
and M are missing, sir.
yes, P is m comma n. The set P is m comma n. And Q is also m comma n. I can say both are same sets, equal sets. But I have to get four ordered pairs when I'm cross product. P comma Q should be m comma m, m comma n, n comma m, and n comma n.
N.
But he is missing 2 ordered pairs. That means he is missing one relation. If I'm saying P and Q relation is P is equal to Q, then that relation is not coming in the cross product of P and Q in the given statement. In the given statement, it is not coming. So this is wrong. The total number of ordered pairs according to definition is 4 because 2 elements into 2 elements. Whether it is equal sets also, it should be same elements. M comma M means both the elements is same. You are taking the equal elements. Same element of P is mapping to same element of Q. So the statement is wrong. What is the correct statement? The correct statement is M comma M, M comma N, N comma M, N comma N. Now it is correct. You will give any relation from P to Q. In the given data, if I am giving element of P is equal to element of Q, then I am not getting whatever the ordered pair I am getting, it is not there in the cross Cartesian product. So then the statement is wrong. Whatever the relation you develop, that should be belong to this Cartesian product. Then only my statement is correct here. That is the purpose of the Cartesian product. What it means? Understood, guys? What is the meaning of Cartesian product and its elements and what is its purpose? When I am deriving some relation, you may understand what kind of elements you may get in that relation. Possible number of elements are possible elements, not possible number of elements, possible solutions you can able to get from the Cartesian product. Is it clear? Guys, anyone having any doubts? Please. Shall I wind up the session? Shall we continue with the tomorrow class? All these things and we'll start the relations tomorrow.
Okay,
Guys?
Okay, sir.
So just go through the basics of what is in Cartesian product, what is the meaning of relation, what is the purpose of mapping. All these things, just go through it. Tomorrow we can start the discussion with the doubts and we will move further. Yes, somebody is
Sir,
asking.
Sir, the thing is that like they are the relations are in curly brackets now, sir, but they are not under. They are not a set now, sir.
No, relation is a kind of set only. How you can say relation is not a set?
Sir, so then the order pairs, if the numbers are repeating, then it should not be there, sir, under a set.
No, in the set, if the same order is repeating, how it is same order is repeating? Suppose how you can write the m comma m, you won't write 2 times now.
Yes, sir, but if there are other numbers like 2, 4, 1 and 2, 5, 7, then at that time, uh, like some, if any same element repeats, sir, then under a set rule, we should not include the
You
repeating.
can write set P is 1 comma 1, 2 comma 2. You can't write now. One element is there. How many times it is repeating? It is a part of the set P only now. See, suppose what's your name? Sorry,
Sir, Raghav, sir.
Raghav. You are a student in school and a student in some academy. You are a, like son in family. If I'm saying particularly I'm taking is school, you are belongs to one particular class, you are belongs to one particular house, you are belongs to one particular like one particular group, math group, and you are belong to some games. If you are playing the team. But if I'm asking you form the class, means you are, because you are in math class, because you are in physics class, they won't write your name in 2 times or 3 times in your class. Am I right, guys?
Yes, sir.
You will get only one time now. Suppose if the set of elements, one is an element, means even though this element is using in many places, in the set it will write only one time. Is there any set you saw any elements are repeating?
No, sir.
Collection of elements is set. Then what is the need of repeating? Suppose if I am asking you list out your names for playing the games, whether you play 3 games or 4 games, you will write your names only one time only, no? Correct?
Yes, sir.
But if I am asking you, suppose list out the games who is playing cricket, means you will write your name only one time, whether you are playing for 2 groups or 3 groups. Correct?
Okay, sir.
What I am saying?
Yes, sir. Got it.
Your name available in different number of sets, but in a set your name will come only one time. Am I right?
Okay, sir.
What it? Suppose your 11 players are required. You can play batting, bowling, and as well as keeping. They won't take as a single player in 3 places. Am I right?
Yes, sir.
Not only that, set means collection of elements. Why? What is the need of repeating that element? No need to take 3 times now. That element is there in that set. That's it. So then there is no possibility of repetition of Cartesian product. Any? Can you give an example? Tomorrow you think over it and can you give an example?
Okay, sir.
Yeah, try. If any situation comes, we will discuss according to that. So guys,
Okay, sir.
we'll meet in the next class. We'll meet in the next class. Bye.
Thank you, sir.
Thank you.
Thank you, sir.